In the previous class, we were looking at the waveguide junctions.
Waveguide junctions.
Okay, and in the waveguide junction, we considered what do we mean by a junction and what is the general structure. Okay, we considered a junction with the four different ports.
Yeah.
Right, to each of the port, we can connect microwave devices, and we can make sure that energy that is fed from one side, right? We can make it to propagate through the junction, and we can different we can convert that into different proportions, and we can make it to available to various sources connected, various devices connected. Okay, then we considered a circuit equivalent, right? And we try to apply the nodal analysis to the junction part, and from there we try to derive what is called as a scattering parameter, right? So ultimately we could understand that we can try to write a matrix notation, right, for the calculation of the energy available at various ports, provided we know what is the amount of energy that is incident. Okay, from one of the side, one of the yeah, to the port we give as input, right? That is considered as port I, and wherever you take out the power, we consider that as a port J. From I to J, the amount of energy that uh, that propagates, right, can be represented by using a parameter called as S parameter. And the S parameters all together, if you write in the form of a matrix, right, that is called as a scattering matrix. So there are some properties of the scattering matrix as well, right? We have considered those parameters, those properties also. Okay, so now we are continuing from here. So we will be looking at various junctions that are possible. Okay, so we'll start with the first junction.
Okay.
So the junction number one is called as H Plane Tee Junction.
Yeah.
H plane. This is T junction. Right. So in order to create a H plane T junction, right, we will cut a rectangular slot along the width of a main waveguide. Right. So there will be a length, there will be a width. Right. Along the width, we try to make a hole, right, in the main waveguide. We'll consider that there is a main waveguide, right? That main wave in the main waveguide, we'll try to make a slot, and we'll try to take out a side arm from that. That side arm is what is called as a H arm, right? So let's try to draw a diagram first so that this becomes clear, right? So let's say,
Okay.
so this is one side of the main waveguide which we are talking about. Okay, so on the
Okay.
other side, we are going to have another. Okay, so if it is starting from here, let me say okay, it starts from here. 1, 2, 3, 4, 5, 6. Okay, this is okay. So we'll connect this. Okay, now let's say this has a height. So this much. 1, 2, 3. Same thing. We will be till this. Okay, so the same thing will be coming even on the other side, so that this is the main waveguide which we are talking. Okay, so from one side, we'll call one of the side as a port 1. Okay, so that's the port number 1. Normally we assume that power is fed from there. Okay,
Yeah.
now what we do, we'll try to see, this is the main waveguide. I can actually connect something like this, and from the middle I'll take out one portion, right? assume that there is a hole is being made over here. Okay, so from this point,
Okay.
we are taking out, uh, say something like we are connecting another part here. So this is the edge, what you call as a side arm, right? So there is a side
Okay.
arm being drawn from this side, so something like this. Okay, and so it's hollow over here. So let me erase this part. Okay, so this part is not there.
Hmm.
This is not there. Also, let me erase them. Okay, so this is all. So this is not there. Even this part, let's see. Okay, so we don't have. It's because from there we have actually drilled a hole and then we try to make a connection. Right? So because of that, we can say this is how it's going to look like. All right. So
Yeah.
in order to complete this, let's draw the lines downwards and another line over here, and let's connect. This is connected to this. This is connected to this. So, all right. Now, so we will mark the dimensions as well. So this dimension, vertically if we measure, that is the B. Okay. So this is E. So same thing measures everywhere. If I try to measure this distance, that should be A now. So if I measure this, that will be the B. Okay. So everywhere, every port, it's going to be the same. All right. So now we'll name the ports. This is port number 1. Okay. So this side will be the port number 2, and
Hmm.
this is port number 3. Right. So normally in case of whenever we try to use this, right? So this is how the energy propagation takes place, right? So we fed,
Hmm.
this is just one example, even you can give from the other side. From one side, you feed the energy. Okay. This is how the energy
Yeah.
propagates. And this energy uh, gets splitted into two parts. Okay. So one part
Hmm.
will be, it will flow like, just a second. Okay, so I'll draw like this. This energy gets propagated into this direction as well as it gets propagated into this direction, right? So
Hmm.
the whenever I'm giving energy from port 3, the port 1 and port 2 will be considered as the coplanar arms. Okay, let me write that.
Okay.
So coplanar arms. So that means I'm talking about 1 and the port 2. Again, there is a concept of symmetricity coming into picture. So that's called as a plane of symmetry. Okay, so let
Hmm.
me try to draw a plane of symmetry over here. I'll change the color. Right. So let me draw two lines through this. Okay, so this is one line, and I'll try to draw a similar line.
Okay.
Not here. Okay, so I'll try to draw it again somewhere here. Maybe this will come like this, and I'll try to draw it like this. So this is a plane of symmetry. In the sense, if you cut this along this particular plane, right? So you see, we are constructing a plane now. So if you try to divide the, if you try to cut this particular device along this plane, right? What we see, we are going to see that symmetric. So this plane, it's a vertical plane, okay, 90-degree to the surface, right? So this plane is considered as the plane of symmetry, right? So whatever you see on the left side, it's the same on the right side. So that's why this blue colored plane, what you are seeing there, right, is considered as the plane of symmetry. Okay. Right. So this is the simplest possible diagram, okay, showing the constructional features of a H plane T junction. All right.
Okay.
So let's write few points related to this first, okay, before we proceed further. So the first
Okay.
point is like H plane, the T junction is formed by making a cut,
Yeah.
making a say rectangular cut along the width
Hmm.
of the main waveguide.
Hmm.
And attaching another waveguide. So the another waveguide is port 3. Okay, port
Hmm.
1, port 2 was the main waveguide. We actually right had a rectangular slot right at the middle, and we attached another waveguide that is port number containing port number 3 to that location, right?
Hmm.
So the another waveguide in bracket I'll write what is its name. It is called as a side arm.
Yeah.
Okay, it's side arm. So is called H arm.
Hmm.
So side arm is also called as H arm. So port 1 and port 2 of the main waveguide are called as the collinear ports, right? As in bracket I write the port 3 of this one.
Okay.
All right. So there are other two uh, ports present. They are from the main waveguide.
Okay.
Port number 1 and the port number 2 of the main waveguide
Hmm.
of the main waveguide are are called as the collinear ports. So there are the technical names given to this. The other arm, newly attached arm, is called as what? It's called as a H arm. All right. So the
Yeah.
next part is that the why do you call this as a H plane T? Right? There is a specific reason behind that. The reason is the axis of the side arm is parallel to the planes of the main transmission line. Okay, and all the three arms are right a plane of the magnetic field. So the magnetic field divides itself into the arms. In a sense, when you feed the energy, right, in the form of electromagnetic waves, right, the H or the magnetic field is the one which gets divided. All right. So because of that reason, we are going to call this as a H plane T junction. So magnetic field denoted by H, right? So that's why it's called as a H plane. So plane, whenever we are considering the axis, it is related to the H. All right. So let me write that point over here. H plane T is called so because I can say that the axis of the side arm, axis of the side arm is parallel to the planes of the main transmission line.
Hmm.
That's just one point. In addition to this, we will be able to see that the three arms of the H plane T lie in the plane of the magnetic field. Okay, so as the three arms of the H plane, all right, three arms of the H plane T. Okay, so my mistake, it's lie in the plane of the magnetic field. Plane of the magnetic field. What happens is the magnetic field divides itself along the arms. Okay,
Hmm.
so the magnetic field gets divided. Okay, uh, itself into the arms. All right, so now it's we know that there is a similarity between the magnetic field components and the electric field components, right? So when you say when you consider electric field or the electric circuit, we have the basic components such as current, right, and the voltage, right? Equivalent to that, on the magnetic field also we have the corresponding terms. Now, since the magnetic field divides, right, electric field has a voltage, magnetic field has, right, the component which is equivalent in terms of the same thing, which is called as a current. So you see there is another name for H plane T junction. It is called as a current junction. Okay, so right, it is also called as the current junction.
Hmm.
Right. Something like you have current entering and from a point current leave. Current entering equal to current leave means at that node you are applying the Kirchhoff's current law. That is right equivalently on a circuit side,
Yeah.
electric circuit side. So similarly, we can see that H field gets divided. Correct. So that means right you should be able to understand the same thing in terms of the right H component, but we will consider considering that as a circuit because circuit analysis is easier for us. We call it as a equivalent term, which is called as the current. All right, so the name given here is the current junction. All right.
Hmm.
Okay. So now our next objective, we understood what is happening, how the energy is going to flow, which component gets divided, and how it is a symmetric. What is the symmetric plane, and what are the terms used for each of the arm, such as coplanar arms, collinear arms, H arm, side arm, etc. Those terms we defined, right? So now our next objective is to find out the uh, S matrix. Okay. So
Huh.
to find the S matrix of the H plane T junction. Right. So the what is the order of the scattering matrix you are expecting now? It depends upon the number of arms. Right. So since we
Hmm.
have three different ports possible, right? So you can have 3 cross 3 order because you can give a power, give energy from one port. Energy can be taken out from any of the ports, like port 1 itself you can take, port 2 or port 3. So three possibilities, right? So since there are three ports, right? This implies the order of the S matrix is 3 into 3. So let us start with the S matrix. So what do you expect? I should have S11, S12, S13, S21, S22, S23, S31, S32, and S33. So this is what is the required matrix, right? Now, what we expect is, right, we need to find 9 different terms and we'll fill it, right? So we'll go step by step. Almost every derivation, every T junction we consider, we will be following a similar procedure, okay, in order to uh, find its S parameter. So that's our idea. So let's start step by step. Now, we need to find out various Sij values, correct? So in the sense, my intention is to find out various Sijs. I will be 1, 2, 3. J is also 1, 2, 3. What we use in order to find out the S matrix, we use the properties. Previous class, we have discussed the properties of the S matrix. So look at the properties of S matrix and apply those to the particular junction and we'll be able to solve. Okay, so first, so there is a what is called as a plane of symmetry. In the sense, when I give an energy from one port, if the energy gets divided into the other two ports equal, right? So then we say that, right, those ports are symmetric, right? Because of the symmetric property, we already have defined there is a plane of symmetry for this particular device, right? If you remember from the third port, we have drawn a plane of symmetry. We mentioned that, okay, whatever is there on the left side will be there on the right side as well, right? So with respect to port 3, port 1 and port 2 are same. You can interchange, right? Doesn't matter, doesn't change anything. So that will be the first point that is specific to the given T junction. This will change for a
Hmm.
junction which we consider later. All right. So for the given junction, this is the first property that we are going to apply. Okay. So I'll write a point here. So because of the plane of symmetry,
Hmm.
because of the plane of symmetry of the junction, the scattering coefficients, the scattering coefficients S13 and S23, all right, must be equal. Are you okay? So
Yeah.
S13 and S23, they are equal, right? So we'll come to know about this. Later on, we'll substitute everything back onto the S matrix, right? So I'll write S13 equal to S23. Call this as, so we'll give that as some name. So let's call this as equation 1. So let me call this as equation number 2.
Hmm.
Okay, S13, S23 are same. I'll call that as equation number 2.
Hmm.
Right. Now, I don't have any other special feature related to this particular T junction. So I can apply the general S matrix properties, right? So, sorry, from the symmetric property. What do you mean by a symmetric property of S matrix? Try to recall.
Symmetric property of S matrix, sir.
Yes. symmetric property of S matrix. It
Hmm.
says that if you give input from one port and take the output from the other port, right, you can actually
Hmm.
swap that, right?
Yeah.
The S
Uh,
parameter is not going to
the S
change.
parameter
So Sij is equal to Sji,
SJI.
right? So we'll apply that. Now that means this implies I can actually write S12 and S21 are same. Okay, I can also write S23 is equal to S32. But if you look at the equation number 2, S23 can be written as S13, right? So I'll call this as S13. Are you okay? So
Hmm.
use the above equation, equation number 2 over. Then S13 and S31 are also same. Okay,
Hmm.
S13 equal to S31. So you can see that, right? Now the whole S matrix, right, can be replaced only in terms of S12, S13, and I think S11, S22. That's all. I'll go to the
Yeah.
next. I'll add another point. So let me call this as equation number 3. I'll add another one. So there is a very specific feature, very peculiar feature of this H plane T junction. Okay, so the
Hmm.
H plane T junction follows what is called as there is a perfectly matched junction for third port. With respect to the port number 3, it is a perfectly matched in the sense no reflection. Okay,
Hmm.
so uh, since the port 3 is perfectly matched, right? For in any of the H plane T junction, this condition will be satisfied. So
Hmm.
perfectly matched means you give input from 3, you cannot take output from 3. So that is S33, it's equal to 0. No scattering happens when you give an input from 3, you don't get energy from 3, right? So using 2 comma 3 comma 4, 2, 3 and 4 in
Hmm.
1, right? Now you update. So this is how you update. So S matrix becomes equal to S11, it's unique, there is no other term. Let's write S12 as it is, S13 as it is. But you see, whatever I write here, it will be equal to S12 itself. I don't have to write S21. S21, S12 are same. S22 is unique. Okay. S23 and S13 are same, right? So I can
Hmm.
write S1, right? So S31 and S13 same. Once again, I write S1. Okay, right? So
Yeah.
S13. So if I write S13 here, I can also write S13 here. Correct? So this is 0. Now you see we are coming closer, right, to the final answer. Let's call this is equation number 5. Okay. Do you
Okay.
have any doubt so far? Writing up
No.
equation number 5?
No. No. No.
No, right? Okay. So
No.
let's proceed further. Now the next, okay, let's apply another property from the properties of the S matrix. It says that it is a unitary matrix. S is unitary matrix
Hmm.
since S is unitary. What do you mean by unitary? You take S and S conjugate, right?
Yeah.
It will be equal to identity matrix, right? So that means let's try to write the this matrix as it is. First one is S11, S12,
Hmm.
S13, S12, S22, S13, then
Hmm.
S13, S13, 0. So this is the first matrix. Second matrix will be the conjugates of each of the term, whatever you have. Correct? So that means it
Okay.
is, this will be, say, S11 conjugate, S12 conjugate, S13 conjugate, S12 conjugate, S22 conjugate, S13 conjugate. Then we have S13 conjugate, S13 conjugate, and 0. Right? What should be the
Hmm.
result? Result should be identity matrix of the same size. So 0, 0, 0, 0, S10 0 0 1.
Okay.
Right. So now let us try to multiply the term by term so that we can equate something. So how do you get this? If I try to multiply the first row with the first column, I should get the first
Hmm.
element, right?
Yeah.
First element on the right hand side. So let's do that. So this implies S11 into S11 star plus S12 into S12 star plus S13 into S13 star. How much? That is equal
Yeah.
to, on the right hand side, you can see that this is equal to how much? It is equal to 1,
Hmm.
right? But if you remember the basics, right? Any from maybe mathematics, right? Complex number, A into A star can be considered as the magnitude, correct? Magnitude of S1. So this implies I can update this as magnitude of S11 square plus
Yeah.
magnitude of S12 square plus
Hmm.
magnitude of S13 square, that is equal to, that is equal to 1. Hope you are fine with this. So
Yeah.
I'm going to
Yeah.
call this as let's hold on to this part. I think this is what we are going to call it as equation number say 6. Okay, we'll be calling this as equation number 6.
Hmm.
Right. So let us try to do another way. So second row into second column you perform, because wherever I get 1, I'll try to write that. So if you consider, say, this row into this column, right, you will get this value, that is 1, right? So I can actually
Hmm.
equate, because others are 0, I may not be able to get anything out of it. So I'm trying to write the equations which, when we take a product, right, dot product, we get equal to 1. That's what we are trying to write first.
Hmm.
Okay, so let's do that. So this implies, also I'll write, that is S, right, this is S12 into S12 star. Directly I can write a square, right? I'll say one step, right? So plus S22 into S22 star is S22 square magnitude, then plus
Hmm.
S13 into S13 star, it's also square. That's also equal to 1. So let me call that as equation number 7.
Okay.
In a similar fashion, you can multiply the third row into the third column, right? To
Hmm.
get 1 once again. So let's do that. So this implies I can also write S13 into S13 star is a square, plus once again S13 into S13 star is magnitude of S13 square.
Hmm.
So how I am writing? I'm writing that from the third row into third column. Okay,
Yeah.
that is also equal to 1. Okay, we'll call that as equation number 8. So out of these three, I think you can use the third one to get one of the parameters.
Hmm.
Right? So from 8, I can actually write 2 times magnitude of S13 square equal to 1, isn't it? S13, S13.
Hmm.
So that implies I can say that magnitude of S13 square is equal to 1 by 2, right?
Hmm.
So that means S13 is equal to 1 by root 2. So we got one of the
Yeah.
parameters. Let's call this is 9. Now I can use this, right? Maybe I can use this to the previous equation, maybe, or you can use it in any other equation. Let me compare. Can I do something? Yeah, okay. Let's compare something, and let's bring another equation in place. Compare equation number 6 and equation number 7. So you see 1, 1, no problem. S13, S13, they are same. You see S12 and
Hmm.
S12, they are same. This means these two have to be same, right?
Hmm.
S11 square and S22 square, it says that, right? From comparing equation number 6 and 7, the right hand sides are same, correct? So the right
Yeah.
hand sides are same means, so even the left hand sides should match. When I compare the left hand side, when I equate them, right,
Hmm.
S1 to S1 to cancels, S13 S13 cancels. What remains? S11 on
Hmm.
one side, S1 S22 on the other side. So because of that, now I can say, so we are comparing 6 and 7. All right. So just to write this, okay, let me write in this way. Comparing equation 6 and 7, I'll directly write the answer. We get S11 being equal to S22. So let me call this is equation number 10. Right? So I'll go back. I'll go back to maybe,
Hmm.
okay, let's check. Let's go back to the equation. I will multiply the third row and the first column. So that means, right? Consider the third row. This is the third row,
Hmm.
and this is the first column. Okay. So third row, first column means I'm getting this answer. It is equal to 0. All right. So I know the right hand side is 0. But let's do that. This is going to help us, right? So we'll get
Okay.
some more terms from this. That's why I'm trying to do this. Okay. So I'll just write here. Okay, just
Hmm.
for your reference, I'll write R3 into C1. So that R3 into C1. Okay, so first matrix row
Hmm.
3, second matrix row 1. Sorry, column 1, my mistake. Okay, so that means R, okay, R I already wrote, so let me correct that. So R3 into C1. This means I'm multiplying S13 into S11 star plus S13 into
Hmm.
S12 star,
Hmm.
right? This says it is equal to 0,
Yeah.
right? Now you see, let me try to do one thing. Let me take S13 outside. Okay, S13, this is S11 star
Hmm.
plus S12 star equal to 0. I already know that S11, right? S13
Hmm.
is not 0, right? So this
Yeah.
implies S13 already known. S13 is already, we have an answer. This is not equal to 0. This implies the S11 star plus S12 star should be equal to 0, isn't it?
Hmm.
Right? So that means S11 star should be equal to minus of S12 star.
Hmm.
Right? So you can, since both are the conjugates, right? We can cancel the conjugation. We can simply write S11 is equal to minus of S1. So let's call
Hmm.
that as equation number 11.
Okay.
Is it fine?
Yeah.
All right. Now S11 and S12, they are same but opposite in magnitude. Correct? So
Hmm.
look at an equation where we have S11 and S12 already they are present. Right? Equation number 6. Okay,
Okay.
just see. We have S11, we have S12, we have S13, out of which S13 is known to you, isn't
Hmm.
it? So 6, I'm going back to equation number 6 now. So, okay, so that is
Hmm.
fine. So 11 in 6.
Hmm.
So let's substitute. Okay, so we are trying to substitute this back over there. Okay, suggest me what we can write. First term as it is S11 magnitude
Hmm.
squared plus, see the second term is S12 magnitude square. So S12 magnitude square minus cancels out. It becomes just S12 square. I can replace it as S11 square. Correct?
Hmm.
Plus the third term. What is the third term? S13 square. S13 is known. 1 by root 2. So 1 by root 2 square is 1 by 2. Right hand side equal to
Hmm.
1. Are you okay?
Yeah.
Okay, so now we got this and let's calculate S11. So 2 times S11 square is equal to 1 by 2.
Hmm.
Is it okay? So
Yeah.
that implies what is S11 square? 1 by 4.
Hmm.
So that means what is S11? square root of that, so 1 by 2.
Hmm.
When we say S11 is 1 by 2, right? So this is, let's say, equation number 12, right? So
Hmm.
put 12 in 11, right? So
Hmm.
you will be able to find out S12 is equal to minus of S11, so minus of 1 by 2. Call
Hmm.
that as equation number 13. Okay. Yeah, and also we have seen one of the equation earlier. Somewhere we proved, yeah, from 10, you can see that 10th one says that, equation 10 says that S11 and S22 are equal,
Hmm.
correct? So 12 in 12 in 10, that gives. So
Hmm.
we'll be able to calculate the S22. S22 is equal to S11, so that will be 1 by 2. Or this
Hmm.
S22 is equal to S11 equal to 1 by 2. Call this as equation 14. Right? I think we got each and every value, right? So we
Hmm.
will fill out the S matrix. Therefore, the S matrix equals to, so look at the S11, 1 by 2. S12 is minus of S11, so minus 1 by 2.
Hmm.
S11, S13, so S13 initially calculated 1 by root.
Hmm.
Okay, and this will be same as minus half, so this is minus half. S22 is half, same as S11. Okay, and S13, S23 are same, so 1 by root 2. So if that is 1 by root 2, I can write 1 by root 2 here. I can write 1 by root 2 here, and the third term is 0. S33 is equal to 0. Okay, so just go through this once and let me know if you have any doubt.
Hmm.
No doubt, right? Okay, let's proceed further. Now, using this S matrix, we will be able to calculate the output from any of the port, provided you know the inputs, right? So
Hmm.
we know that we can write matrix B is equal to matrix S into matrix A, right? This is a general
Hmm.
equation that is applicable for any of the junction, right? Now we'll write specific to this junction. B should be three different values because there are three ports, correct? So let me write, this is B1, B2, B3. It's a column matrix or it's a vector, okay?
Hmm.
So this is equal to, I am supposed to write the S matrix. So directly write the values of S matrix, okay? So 1 by 2, minus 1 by 2, 1 by root 2, minus 1 by 2, 1 by 2, 1 by root 2. This is 1 by root 2, 1 by root 2, 0. All right. So this is S. Multiply this with the inputs. Again, how many inputs are possible? The number of inputs that you can give here is equal to 3, right?
3.
It should be 3. So A1, A2, A3.
3.
Right. So this means I can write a set of equations, correct? Corresponding to
Hmm.
what is the probable output that you can get at each of the ports. Provided you know the A, B, C values, you can write, correct? You can actually calculate, but right now our intention is not to calculate, right? We will try to provide the, get the equations first. So this implies, first give me the equation for B1. B1 is equal to 1 by 2 times A1 minus 1 by 2 times A2 plus 1 by root 2 times A3. right? Simple
Hmm.
multiplication. P1 value comes because of the multiplication of the first row of the first matrix, square matrix into the column vector. That is A1, A2, A3. Similarly, write what is B2. B2 is equal to minus 1 by 2 A1 minus, is it minus? I think plus, right? So second term will be plus. So plus 1 by 2 A2 plus 1 by root 2 A3. And what should be B3? B3 is equal to 1 by root 2 A1 plus 1 by root 2 A2. Okay, so just
Hmm.
understand, let us say A1 and A2 are zeros. Let's assume I'm not giving any input to the first port and the second port, and I'm giving the input only to the third. Okay, so
Yeah.
let's try to analyze this in several in various situations. What's going to happen? Okay, so let's use these equations for our analysis purpose. So
Hmm.
this is the first analysis. If A3 is not equal to 0, which means there is some input in the third port, and A1 equal to A2 equal to 0. No input is provided from the port 1 and port 2. Is that clear?
Hmm.
Okay. Under such condition, what happens to the outputs? What is a B1? This implies, can you tell me what's the value of B1 equal to? What is the value of B2 equal to? And what is the value of B3? So you just have to use
Okay.
the above
Is
equations.
not equal to 0 and A1 and A2 are 0.
Right.
B1 would be 1 by root 2 A3.
Yes. So I can
B2
write
1 by root 2 A3.
A3 by
B3
root
is
2,
0.
A3 by root 2, correct?
0.
And B3 is equal to 0. So you see, when input is given from the third port, it gets equally divided among the first and the
Into
second
the
port.
first and second port.
That's what we discussed initially, right? Now I'm actually
Hmm.
checking whether this S matrix is correct or not. Are you
Hmm.
okay? So yes, this is
Yeah.
right. We whatever we assumed, that is correct. Correct? Now this implies, what is the
Hmm.
meaning of this? It says that P3 is the power that is input at a particular port. This power gets divided equally among the first and the second ports, right? So that's what is the meaning. So we need
Hmm.
to write that. So this implies, right? If, say, I'll write P3, okay, denotes the input power. It denotes the input power at port number 3, right? Then it gets divided. It gets divided equally
Hmm.
between ports ports 1 and 2. So let me try to write in this way. Okay, so the power P3 is equal to power at the first port plus power at the second port. Is it okay? But
Hmm.
they're equal. P1 and P2 are equal. So I can also rewrite this as is equal to 2P1. That's also equal to 2P2.
Hmm.
Right? Now let us try to calculate. The calculation is amount of power coming out of first port or the second port because of the input at the port 1, port 3, right? I'm trying to calculate that, right? So therefore, this is the important, what you call, observation that we are going to make from this. So
Hmm.
the amount of power coming out of the port number 1
Hmm.
or the port number 2 due to input at port 3. So how do you calculate? Let's try to calculate in the decibel scale, right? This is the calculation. So simple calculation already we done. Okay, we have done that. P3 is equal to P1 plus P2, 2 times P1, 2 times P2, we have. Okay,
Hmm.
so now the calculation happens on a log scale. So since it is power 10 log, okay, 10 log, the power output at first port, power input at the third port,
Hmm.
correct? This is also equal to 10 log power at the second port, power at the third port. Is it okay?
Hmm.
Now, can you get me a number here, right? Can you solve this? And can you try to get a number here? Take your time, no problem. Because we already know something, right? Use the equations above and try to get a value. Substitute for P1, P3 if possible, and get me a number.
Substitute the values for P1, P3.
Correct. You can use P1, P2 or P1, P3, P2, P3, anything. Anything you can use
Hmm.
and try to get a value.
P1, P2, P. Okay. 10 log of. Just a moment.
Sure, sure. Please take your time, no problem.
It would be minus 3.01.
Right. So you can put P1 by P3 as a 10 log of, if you take that as 1, this is 2, right? So 1 by 2
Yeah.
in both cases. So 10 log of this is
Minus 3.01
minus 3.01. This is in the decibel scale,
decibels.
right? So you see there is another name given to the H plane Tee junction, right? You see whenever input is given in the third port,
Hmm.
what comes at the first port or the third port is 3 dB lesser than what you have given,
Yeah.
right? So there is another name called, this is 3 dB splitter.
Ah.
The name is 3 dB splitter. When people say 3 dB splitter, they should understand that they are talking about a H plane Tee junction,
Yeah.
right? So that's the first thing. And let's move on to the second analysis. Let me say that we are giving input to A1 or A2, and that is equal to some value A, and we are not giving any inputs to the third port.
Hmm.
My mistake, what I write. A3 equal to 0, not A3, not equal. So no inputs to the third port.
Hmm.
Okay, so this is the second part of the analysis, right? Now, if you try to write the equation, what happens? Let's try to write the first equation. First equation is B1. So
Hmm.
B1 equal to, it's A1 by 2 minus A2 by 2, that is also A by 2, plus A3 by root 2, correct?
Yeah.
All right, so that means first two terms cancel. A3 is 0, so this is equal to 0, right?
Yeah.
You give input at the first port as well as the second port. Their equal inputs are given, right? Nothing comes back to the first port,
Hmm.
right? That's the first thing. Then calculate a B2. B2 is equal to minus A by 2, right? Minus of A1 by 2, which is A by 2 in this case, plus A2 by 2, that's also A by 2. And the last
Hmm.
term is plus A3 by root 2. This is also 0,
Yeah.
right? A3 by 2 equal to 0. So you see that again, nothing comes at the output of the second port when you give equal input from A and B. Equal input from first and the second, right?
Hmm.
Let's calculate what comes at the output of the third port. That will be B3. B3 is equal to, it's A by root 2 plus A by root, A1 by root 2, A2 by root 2 plus 0. So that
Hmm.
means it's simply 2 times A by root 2, correct?
Hmm.
So 2 times A by root 2. So can I write it as root 2A?
Yeah.
Okay. So when this means if you give equal inputs from A and from port 1 and port 2, they get added and the result is available at the port. Okay.
Hmm.
So this implies the sum of inputs at port 1 and the port 2. Okay. Sum of input at port 1 and port 2. Sum, since I'm using sum, I'll use, okay, sum of port 1 and inputs at port 1 and port 2 is, is, is available at the port number 3, right? So whatever we are seeing now, right? So two parts of analysis we have done. So that is all we need to know about the H plane T junction. Okay.
Hmm.
So do you have any doubts with what we have discussed so far? So the H plane T
No.
junction is over.
Yeah.
All right. So go through this once again, and if you have any doubt, I'll solve that.
Okay.
Okay. Otherwise, we'll move to the next, that is E plane T junction in the next class.